Okay, so hello. Okay, so today we are going to discuss about the polynomials exercise 2.2. So first of all, we are going to discuss about the relationship between zeros and coefficient of a polynomial. Suppose let us consider let alpha and beta zeros of polynomial px is equal to ax squared plus bx plus c, where a is not equal to 0. So therefore x minus alpha and x minus beta
बेटा नहीं बिजली का बिल
okay, so there once again okay, so therefore x minus alpha and x minus beta factors of polynomial px. So we can write like that: ax squared plus bx plus c is equal to, how can we write? K is a constant term, x minus alpha into x minus beta, right? So where k is a constant, it is a constant. Suppose let us consider alpha and beta zeros of a polynomial. Okay, px we consider a quadratic polynomial ax squared plus bx plus c, where a is not equal to 0. So therefore x minus alpha and x minus beta factors of px. If alpha and beta zeros of a polynomial, then x minus alpha and x minus beta factors of polynomial px. So we can write the polynomial px will be k into alpha x minus alpha into x minus beta, where k is a constant term. So we can write here x squared plus bx plus c is equal to k into x squared into x squared, this one, minus beta x, okay, next minus alpha x, minus plus alpha into beta, so which is equal to k into x squared minus alpha plus beta into x plus alpha into beta. So if we comparing both sides, this is left hand side and right hand side, what we will get? Ax squared plus bx plus c is equal to what is the one? K into x squared minus alpha plus beta into x plus what? Alpha into beta. So if we compare both sides, what we will get? what will get a equal to k, b equal to minus k into alpha plus beta and c equal to k into alpha into beta. So therefore alpha plus beta is equal to what? Alpha plus beta equal to what? Minus b by k. So what is k? It will be minus b by a. So alpha plus beta is equal to minus b by a. This is the relation. And another relation is there. Alpha into beta is equal to c by k. So what is k? C by a. So this is the relation between zeros and coefficient of a polynomial. So n, b and c are the coefficient of, a is the coefficient of x square, b is the coefficient of x and c is constant. So these are the relation. Okay, ठीक है अंशुमन, got it? Okay, now done na? This one done. Okay, done. Write down it. Okay. Okay, done na? Okay, next page. Good, right. This is the next page. You can write. Okay. Okay. So again, বুজাই দিছো বাৰু. So we'll repeat again. So let's see. we consider alpha and beta. This one we consider alpha and beta zeros of the polynomial. So what is zero? Already we discussed about this one. So what is zero? The value of x where the px will be 0. Suppose if we put the p alpha, then the value will be 0. When we put the value of alpha in terms of x, then we get the equation will be 0. So p alpha will be 0. So this is called zeros of the polynomial. So already we have discussed this one. So alpha and beta zeros of the polynomial px, right? So therefore we can express this one like that. So x minus alpha and x minus beta be the factors of polynomial px. So there is a if we express this one like that, we can write here x square plus bx plus c is equal to k into x minus alpha and x minus beta, like that. So where k is the constant. Okay, so x square plus bx plus c, we can write here k into x square minus beta x minus alpha x plus alpha into beta. So which is equal to k into x square minus alpha plus beta into x plus alpha beta. So this one clear? So finally we can express this one like that, x in k into x square minus alpha beta x plus alpha beta. So we can write one like that, this one x square plus bx plus c is equal to kx square minus k into alpha plus beta x plus alpha into beta. So comparing both sides, so here x square, here kx square, so L will be k, bx here and minus k alpha plus beta. So we can write b equal to minus k into alpha plus beta and c equal to k into alpha into beta. Okay, so therefore alpha plus beta is equal to, we can write from this equation alpha plus beta equal to minus b by k, and therefore alpha plus beta equal to minus b by a, where to k equal to a. So therefore alpha plus beta is equal to, you can write minus b by a, and alpha into beta here c by k. So alpha into beta c by a. So finally we can write here alpha plus beta is equal to minus coefficient of x divided by coefficient of x square, so which is equal to minus b by a. This one the relation, and alpha into beta is equal to c by a which is equal to constant term divided by coefficient of x square. This is the another relation. Okay, Ansuman, got it? Clear? Okay. Okay, this one done na? Okay. So similarly for cubic polynomial, Similarly for cubic polynomial. So like that, px equal to ax cube plus bx square plus cx plus d is the cubic polynomial where a is not equal to 0. Then alpha, if alpha, beta and gamma be the zeros of this polynomial, then we can write alpha plus beta plus gamma is equal to minus b by a, alpha beta plus beta gamma plus gamma alpha is equal to c by a, and alpha beta gamma which is equal to minus d by a. These are the relation between coefficient and zeros of the polynomial for cubic polynomials. So this one relation, and there is a 3 relations. So this one 1, 2 and 3. So alpha plus beta plus gamma is equal to minus b by a, and alpha beta plus beta gamma plus gamma alpha equal to c by a, and 3 relation alpha into beta into gamma equal to minus d by a. Okay, so remember it, very important formula. Okay, okay, note down. Done. Okay, okay, now we are going go to the exercise 2.2, question number 1. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and coefficients. So question 1, x squared minus twice x minus a. So we let px equal to x squared minus twice x minus a. So we can express this one 4 to the 8, right? 4 to the 8, that is why x squared minus 4x plus 2x minus a. So which is equal to, x is a common, x minus 4 plus 2 x minus 4, which is equal to x plus 2 and x minus 4, right? So we can express this one now. So if px is equal to 0, then what we write, x plus 2 whole into x minus 4 is equal to 0. Therefore x plus 2 is equal to 0 or x minus 4 equal to 0. Therefore x equal to minus 2 or x equal to 4. Therefore zeros of this polynomial, zero of the polynomial px is equal to minus 2 and 4. So minus 2 and 4 is the zeros of this polynomials. Okay, note down it. Done. Yes, send us. Okay. ইউটিউবত কোন কোন আছে 6 watching now. Ankur. Okay, done. Answer one done. This class is live on app as well as YouTube also. Okay. Okay. We're going to done. Okay. So what is the relation? So we get the one solution. Here alpha is -2 and beta is what 4, right? Alpha is -2 and beta is 4. Therefore alpha plus beta is equal to -2 plus 4, right, which is equal to 2. We can write here like that 2 by 1. Here minus and again -2 by 1. So minus it will be plus. So minus it will be what? Plus. So we can write here minus coefficient of this one x -2 and the coefficient of x square. Here the coefficient of x square is 1 and the coefficient of x is -2. So we can express this one like that. So we verified the relationship between zeros and the coefficients. So first of all, the first relation alpha plus beta is done, and alpha beta, which is equal to alpha and beta -2 into 4, which is equal to -8. So we can write here like that -8 by 1. So which is equal to -8 is a constant term, this one constant term. So we can write constant term divided by coefficient of x square. Okay, so hence proof or verify. You can verify this one. Okay, got it? Okay, Ankur, Senas, Dimple. Yes, got it? আজি আমি CBSE ক্লাস লৈ আহিছোঁ ইউটিউবত। question khini pray eke hoy, but we explaining in English only. Okay, done. Fine. So next question number 2. 4s square minus 4s plus 1. So question number 2, px is equal to 4s square minus 4s plus 1. So therefore we can write like that: 2s square minus 2 into 2s into 1 plus 1 square. That means s square minus twice ab plus b square. So which is equal to twice s minus 1 whole square. A minus b whole square equal to s square minus twice ab plus b square, like that. So you can write here 2s minus 1 whole into 2s minus 1. So if px equal to 0, that means 0 of this polynomial, then what we can write? Then twice s minus 1 whole into twice s minus 1 is equal to 0. So twice s minus 1 equal to 0, or twice s minus 1 equal to 0. Therefore twice s equal to 1 or twice s equal to 1. So s will be 1 by 2 or s will be 1 by 2. So therefore zeros of this polynomial px alpha is equal to half and beta also half. So these are the zeros of this polynomial. So alpha and beta all are same. So in this polynomial the zeros of this polynomial are equal. So alpha equal to half and beta equal to half. Okay, Suman. Someone done? Okay. So therefore we can write alpha plus beta is equal to half plus half. So which is equal to what? 1. Now alpha plus beta is equal to half plus half, it will be 1. So what is the equation? This one, minus 4s square minus 4s plus 1. So we can write here minus 4 by 4. So minus plus and 4 cancel out, it will be 1. So which is equal to minus coefficient of x, right? Coefficient of x is the, sorry, here coefficient of s will become, so coefficient of s is -4 and the coefficient of s square, so this one 4, coefficient of s square is 4, so our first relation is verified. And alpha plus beta, sorry, alpha into beta is equal to half into half, so it will be 1 by 4, so which is equal to constant term is 1, constant term is 1 and coefficient of s square. So coefficient of s square is 4, so 1 by 4. So second relation also verified. So question number 2 is verified. Okay. Okay, carry on. Okay, done na? Yes, Angsuman? Okay. Angsuman kiba koba? Okay, so next go to the question number 3. Question number 3. Okay, so px is equal to 6x square minus 3 minus 7x. So we rearrange with this one, 6x square minus 7x minus 3. So how can we express this? Six threes are 18, right? Okay. Okay, so this one 6x square minus 9x plus 2x. 6 3s are 18 and 9 2s are 18. Okay, so this will be minus 3. So this one 3x common as a common, so 3 2s are 6 minus 3 3s are 9 plus 1 2x minus 3. So which is equal to 3x plus 1 whole into 2x minus 3. So if px equal to 0, then what? 3x plus 1 whole into 2x minus 3 will be 0. Therefore 3x plus 1 equal to 0 or 2x minus 3 equal to 0. Therefore 3x will be minus 1, hence x equal to minus 1 by 3. And here also 2x equal to 3, so this implies x equal to 3 by 2. So therefore zeros of this polynomial, therefore zeros of the polynomial px is equal to alpha equal to minus 1 by 3 and beta will be 3 by 2. These are the zeros of this polynomial. Okay. Okay, note down. Hello Akash, where are you from? Compartment like कोई problem नहीं है. We are providing the videos of exercise. Where your exam? You can contact us. If you want to help from us, then you can contact our numbers coming on the screen. 940173523. You can contact. Okay, we'll help you. Angshuman, you have done? Okay. So similarly, you can check question number 3. Alpha plus beta will be how much? So here alpha is minus 1 by 3 plus beta is 3 by 2, right? Beta is 3 by 2. You can check this one. So what is the LCM? 6 minus 3 2 is 6, so plus minus 3, sorry, minus 2, and 3 3 is 9, so which is equal to 7 by 6. Okay, so which is equal to 7 by 6. So we can write here minus 7 by 6 here. So what is this one? Minus coefficient of x is minus 7 coefficient of x divided by coefficient of x square. Okay, and similarly first relation is proof or verified. Alpha into beta is equal to minus 1 by 3 into 3 by 2. 3 cancel out, it will be minus 1 by 2. So constant term is minus 3. Constant term is minus 3 and 6. So this one, right? So we can write like that, 3 by 6. So this one, constant term is minus 3 and coefficient of x square is 6. So this one verified. This one also verified. Question number 3 done. Okay, fine. Next, we are going to the question number 4. Question number 4. Pu is there. 4u square plus 8u. Okay. So, how can we solve it? It's very easy. Into plus 0. You can write 0 in terms of constant term. Okay. So here we take common. 4u is a common. So 1 u plus 2. You can write like that. 4u is a common. 4u into u is 4u square plus 4u into 2 is 8u. So therefore, if Pu is equal to 0, then 4u u plus 2 is equal to 0. Therefore, 4u is equal to 0 or u plus 2 equal to 0. Therefore, u will be 0 or u will be minus 2. So therefore, the zeros of this polynomial, alpha equal to 0 and beta will be minus 2. Now we verify the relation. Alpha plus beta is equal to 0 plus minus 2 to be minus 2. So which is equal to minus 8, yes, 8 by 4. So which is equal to minus coefficient of u divided by coefficient of u square. So first relation is verified, and similarly second relation, alpha into beta is equal to 0 into minus 2, 0 will be, which is equal to constant term is 0, right, or constant term is 0 divided by 4, so which is equal to proof. Constant term divided by coefficient of u square. So this one also verified. The relation between coefficient and zeros of a polynomial are verified. Okay, go down. Yes, Subhankar, I have explaining already, and you are asking for some help. How can I express root I in a plus ib from? You are asking from advanced maths, right? Complex number. Okay, you can text us. I will explain you. Okay. Text our WhatsApp number. Already number is coming on the screen. Okay. I will explain you. Okay, fine. So next question number 5. T square minus 15. Very easy. This one also very easy. Px is equal to T square minus 15, right? So we can write T square minus or plus anything else. You can write minus or plus 0 into T minus 15. Okay. So a square if pt equal to 0, then what? T square minus 15 equal to 0. Therefore T square equal to 15, right? Therefore T equal to root over 15. Plus minus root over 15. Therefore the zeros of this polynomial, zero of the polynomial pt is equal to alpha equal to plus root over 15 and beta will be minus root over 15. So plus sum of the zeros, alpha plus beta is equal to plus 15 plus minus root over 15, which is equal to 0. So we can write this one 0 minus 0 by 1. So it will be 0. So 0 is the coefficient of t divided by what? Divided by coefficient of t square. This one verify. And similarly alpha into beta is equal to root over 15 into minus root over 15, which is equal to minus 15. So which is equal to minus 15 by 1. So which is constant term divided by coefficient of t. So which is also verified. So both the relation are verified. Both the relation are verified. Very easy question. Done. Angshuman done. Okay. Can I go to the next question, Angshuman? Okay. So next last question. Question number 1-6. This one. Px is equal to 3x squared minus x minus 4 is there. So here therefore this will be t3 4s are 12, so we can write t x squared minus 4x plus 3x minus 4, right? We can express like that, minus 4x squared, sorry, minus 4x plus 3x equal to minus x. So here 3x plus 3x minus 4x minus 4. We take 3 as a common. Sorry, we take 3x is a common, x plus 1, and here minus 4 x plus 1. So therefore 3x minus 4 whole into x plus 1. So if px equal to 0, then 3x minus 4 whole into x plus 1 is equal to 0. Therefore 3x minus 4 equal to 0 or x plus 1 equal to 0. Therefore 3x equal to 4 or x equal to minus 1. Therefore x equal to 4 by 3 or x equal to minus 1. So 0 of this polynomial, therefore 0 of the polynomial, zeros of the polynomial px is equal to alpha will be 4 by 3 and beta will be minus 1. So alpha equal to 4 by 3 and beta equal to minus 1. Okay. Okay. Done. Okay, fine. So next. So now alpha plus beta, it will become as 4 by 3 and minus 1. 4 by 3 and minus 1. So which is equal to 3 as a common, 4 minus 3. So which is equal to 1 by 3. Right? So 1 by 3. Like this one now. So which is equal to minus 1 by 3. So minus it will be plus divided by 3. So which is equal to minus coefficient of x. So coefficient of x, this one minus 1, and coefficient of x square. Coefficient of x square is 3. So therefore we can write like this: alpha plus beta is equal to minus coefficient of x divided by coefficient of x square, which is verified. And alpha into beta, which is equal to 4 by 3 into minus 1, so which is equal to minus 4 by 3. So therefore constant term is minus 4 and coefficient of x square is 3. So which is verified. So both the relation are verified. Both the relation are verified. Ankur, good night. Done. Also one. Okay, this one done. Also one. Okay. So next, question number 2. Find a quadratic polynomial each with a given numbers as a sum and product of its zeros respectively. So a very important question, this one. So first one, let the polynomial be, let the polynomial be px equal to ax square plus bx plus c and zeros of this polynomial be alpha and beta. So given alpha plus beta is equal to 1 by 4, so which is equal to, we can write minus b by a, and alpha into beta is equal to given minus 1. Our relation is constant term by a. So therefore we can write alpha plus beta is equal to minus 1 minus 1 is equal to plus by 4, so which is equal to minus b by a. Therefore b will be minus 1 and a equal to 4. So similarly alpha into beta is equal to minus 1, we can write minus 4 divided by 4, so it will be minus 1, so which is equal to c by a. So we observe the value and comparing the value of a. So a is constant here, a is 4, so we write here 4, therefore 4 here minus 4, so therefore here c will be minus 4, so we get the value a, b and c, this one. Therefore required polynomial will be what? C equal to minus 4. Therefore the required polynomial px equal to a is 4 x square and b is minus 1, so x, and c is minus 4. So required polynomial is 4x square minus x minus 4 is the answer. Got it, Angshaman? Understand? Understand, no? Question is understand? Solution? Match with the relation. Okay, we are matching the relation alpha plus beta and alpha into beta. Okay. So next question. Similarly, let px equal to x squared plus px plus c. Okay, with a polynomial of the polynomial and zeros of px being alpha and beta. Here given alpha plus beta is equal to root 2, which is equal to minus b by a, and alpha into beta is equal to what? 1 by 3, which is equal to c by a. So from this the relation we will express the polynomial. So from the this one now, therefore here from alpha into beta is equal to 1 by 3, right? So it will be c by a. We comparing this one, so a will be how much? 3 and c will be 1. Therefore alpha plus beta is equal to root 2, right? So which is equal to, we can put 3 here. Okay, 3 into our relation is minus, so minus 3 root 2. Then minus minus cancel out, it will be plus, 3 cancel out, it will be root 2. 3 cancel out, then it will be root 2. So which is equal to minus b by a. So by comparing this one, a equal to 3 and b equal to minus 3 root 2. Okay, so we comparing this one, you get the relation a equal to 3, b equal to minus 3 by 2, minus 3 root 2 and c equal to 1. Therefore required polynomial px is equal to 3 x squared minus 3 root 2 x plus 1. This is the answer. Great. So next, question number 3. Let the polynomial px equal to x squared plus bx plus c and zeros of this polynomial be alpha and beta. Okay, so therefore alpha plus beta, it will be 0, which is equal to minus b by a, and alpha into beta, it will be root 5, which is equal to minus c by a. So by comparing this one, therefore alpha into beta equal to root 5, which is equal to, we can write minus 5 by 1, which is equal to C by A. Therefore C will be root 5 and A will be 1. Okay, so therefore alpha plus beta is equal to, we can write 0 by 1, which is equal to b by minus b by A. Therefore b will be 0. Okay, and A will be 1. Therefore required polynomial, very easy, required polynomial px is equal to x squared. Okay, then p is 0, x squared plus 0 into x plus root 5. So required polynomial is x squared plus root 5 is the answer. This is the answer, x squared plus root 5. Okay, so fine. So this 3 question is there, 4, 5 and 6. This is your homework. So this one 4, 5 and 6. Okay, this one homework, you can solve by yourself. Okay, ठीक है sir, thank you. Four, 5, 6. Okay, Angsuman, good night. Okay, okay everyone, thank you for watching. So you can solve the last 3 questions I have shared already. These 3 questions, 4, 5 and 6. Okay, so you can send us the solution on our WhatsApp number. Already the number is coming on the screen. Okay, okay Dimple, thank you. Okay, this is the first class on YouTube in English medium. Okay, if you want to join with us, then you can text us, okay, or WhatsApp us or contact us. Okay, thank you everyone.